Hello everybody, this is Mr. Kusaj, and we're back with part 2 of chapter 2.1. Remember to put the date there. Radical functions. Radical functions are, just like it says, a function that involves a radical in it. Okay? So you could have a power on the inside and a radical on the outside, just like that. Here's an example. If you're asked to graph, for example, 2 times, right, fourth root of 5x to the third, well, you know what it's going to look like, right? It's going to look like it starts at 0 and just goes up and out, but you can always graph it the old-fashioned way. X, Y, 2 columns, right? X can't be less than 0, so you choose 0, 1, 2, 3, plug them in, and you get these numbers. So this is about 3, this is about 5, this is about 7. So you plug those numbers in, and you do, in fact, get a curve that goes this way. Okay, we knew it was going to be really fast up because he's multiplying numbers, right? Because the regular square root, the regular radical parent graph just goes up like that, gently. Anyway, that's the only way really to graph it, unless you want to use a graphing app. Okay? Solving radical equations, now we're back into algebra. So I put some steps down here. When you solve radical equations, your job, the first job, will be to get the radical by itself on one side or the other, right? You got to get this part alone by itself. Once you do that, you need to cancel it, right? So, for example, if this is third root, right, you cancel it with third power. If this is fourth root, fourth power, etc. So now you got to do that to both sides, right? So we want to cancel the radical with whatever number that is, you match it with the power on both sides. After that, you solve as usual because you won't have the radical symbol anymore. You just use algebra like you always do. Here's an example. We're solving radical equations. So here's an equation and it has a radical in it. Now, this is, do I square both sides right away to eliminate the radical? No, because the first thing we have to do is get the radical by itself. So first thing we have to do is get rid of this negative 2 with plus 2 on both sides. Okay, now that I got the radical by itself, now I square both sides to cancel the radical, and the radical is gone. Okay, now notice this left side here, we're squaring a binomial, right? So FOIL method, 2x squared quantity becomes 4x squared on the left. On the right we get 2 squared, which is 4. In the middle we get 4x and 4x, which is 8x. Okay, I know we did that quickly, but that's just algebra. On this side, the radical sign is gone. So now we just have an equation without a radical, but we do have a square, right? So how do you solve those? The way we solve those is to get 0 on one side. Remember our quadratics? So cancel the negative 12x with plus 12x. Cancel the 100 with minus 100. So everything goes to the other side, and you get 0 here. And now you solve that. How do you solve that? Well, try to factor something out. You can factor out the 4. Now this is all algebra. I know I'm going fast, but this is all algebra. All we're doing now is solving this radical down here. And I notice that I can pull out a 4, so I pull out the 4. Pardon the shadows of my hand there. And now I look at this and see if I can factor this, right? 2 factors, x, 2 numbers that multiply to 24 but add up to 5, and it's 8, 3. get the signs right. So what we're saying here is that one of these is equal to 0. So x plus 8 equals 0. That makes x negative 8. X minus 3 equals 0. So that makes x equals 3. I did it. I solved this equation way up here, and it came out to x equals negative 8 and x equals 3. Okay? The most important part, even though there's a lot of steps in here, the most important part is you start by getting this radical part. The radical part, get that alone. Okay? All right. Moving on. Solving radical equations. Then we have, this is slightly different. Then we have exponents, right? But fraction exponents, rational exponents. So we've seen x with a power, but we've never seen x with a fraction power. Okay, so how do you deal with that? Well, what you can do is change your rational power into a radical form. So x to the power of 5 over 2 is the same as square root of x to the 5th. Okay? The bottom is the radical part. The top is the power part. Okay? So if you already have a function, you can analyze it. Right? So notice the domain and the range. Domain goes from left to right, so it starts at 0 and just keeps going on forever. The range starts at the bottom, goes up, starts at 0 and goes up forever. Okay, intercepts, they both intercept at 0. The limit, what happens in the other end? Well, as you go this way, it doesn't exist. As you go forever this way, there's nothing there. But as you go this way, it keeps going up forever, so it increases to infinity. Continuity, there's no break. It starts at 0 and goes, and there's no breaks anywhere, right? It's solid everywhere. Increase, well, it's always increasing, starting at 0, not including 0, and it increases all the way up. Decreasing, it never decreases, okay? Why don't you try graphing and analyzing, just like what we did up here, this one, right? So to graph it, do the x, y column and just choose for x 0, 1, 2, 3, and you'll get the idea of what's going on. Choose some negative x's too. So how about negative 2, negative 1, 0, 1, 2 for x's. Plug them in and see what you get for y. Okay? We'll do that in class. Okay, finally, this example. I guess it's going back to the equation. Maybe I gave you the rational fraction before this example, and I shouldn't have. It doesn't matter. You still need to know how to solve the equations. So this goes back to the notes that I gave you at the beginning, right? What's the first step? The first step is to cancel the radical here. No, that's not the first step. The first step is to get this thing alone. So the first step is minus 14 minus 14, right? Now that you got the radical alone, now it's your job to cancel it, right? So it's third root, so you cancel it with third power, but you have to do it to both sides. So now on the left, the radical sign is gone, and you're left with x minus 5 squared, whatever that is. And on the right, you have 36 to the third power, whatever that is. There you go. Okay. So on the left, the radical is gone, but now you have x minus 5 squared. So how do you get to the x? Well, to cancel the power 2, you square root both sides, right? It seems like we're putting it back, but we're not putting back the same exact thing, obviously. So we square root both sides. So now the square is gone, and whatever the answer to that is, plus minus, right? So x minus 5 is equal to plus minus that, whatever the calculator says. And then you do plus 5, and you get a large number. Okay, yeah, this is all calculator work in the end. But all you got to keep in mind is that you get the radical alone, and then you use all algebra after that. Okay? So all we did for part 2 was see a few radical functions, right? And then put that aside. That's just a function in the graph, and we can analyze it. Then we have solving radical equations, right? We weren't solving this, we were just graphing this, okay? And then we had functions where you had a fraction power, and you can change that fraction power to a radical symbol where the radical part goes on the outside and the power goes on the inside. And you can graph that and analyze it. All right? That's all we did. Okay. See you tomorrow. Bye.